All right. I hope you guys are doing well today. We are in the building. Good morning, good morning, good morning. Grand risings, rise and shine, rise and grind. Let's get into our lesson for the day. Make sure that as you guys are coming in, that you bring, of course, your periodic table because you're going to need that, as well as your notes, your notebook, your calculator. You need all of the above. So as you guys are coming through, we're going to start preparing you for your lesson for today. And what I want you guys to do as we walk you through these stoichiometry problems, you just have to remember that stoichiometry is something that you will either get the first time or it's going to take you practice to get it the fourth and fifth time. Okay. So what I want you all to do is do these problems alongside with me. So that way you're able to see if you're on the right track. Okay. So I'm going to go ahead and start now. So you all can see exactly what we're doing. And by the way, for those of you that are new to my platform, I do go live Monday through Thursday at 10 a.m. Eastern Standard Time and 7 p.m. Eastern Standard Time. So if you guys are wanting to get the assistance that you need in General Chem 1, come through. Now, if you are here for General Chem 2, we go live at 11:30 a.m. So pretty much right after this one and 8:30 p.m. Okay. So we're going to go ahead and go through a review of where we left off so that you all can kind of get the gist of what we were talking about. So yesterday we were talking about moles, right? And grams and how you actually use that for a stoichiometry problem. So for this one, I'm going to actually walk you through it so you all can see step by step how this whole process works, okay? Now, as I go through the problems again, make sure that you can do them right alongside with me. So that way you will know if you are doing it the right way, okay? So let's look at the first problem. This is a mole to mole problem. And what you have here is a chemical reaction. You want to make sure that you, you said you took General Chem 1, you struggled with stoichiometry. You know what? A lot of students do. But it just takes time to actually master, what they are giving you versus what you have to use. So for instance, in this particular problem, when they say how many moles of water are produced with 3 moles of hydrogen, when 3 moles of hydrogen react with excess oxygen, that word excess oxygen is not even necessary to do this problem. But so many students think that they have to use it because they put it in the problem. But it's almost like decoding a word problem. Okay, you're decoding word problems. So you're basically looking at it to determine what all I need to solve this problem. Okay, so you are decoding it. So I'm going to show you all how to decode this so you will know how to do that as well. So here we are. How many moles of water? That's what we're looking for. So we're going to use a coefficient of 2 to help us solve this. They gave you 3 moles of hydrogen. Okay. You need that 3 moles here, but you also need the 2 moles up there to solve the problem. Okay. So I'm going to go ahead and split this up so you all can see. Let's make a prediction as to what the answer will be. If I told you originally that you had 3 moles of hydrogen, then guess what? Because the two of them both have the coefficients of 2, they're going to also have the same answer. Okay? They're both going to have the same answer. So watch this. I gave you originally 3 moles of hydrogen. Well, after the fact, right? You're looking for water, the number of moles of water. They are technically the same answer because they have the same coefficient. So here's what you're going to do. You're going to say 3 moles of hydrogen, right? And then on the very bottom, you're going to go back to your coefficients And in this box right here, I'm going to use the coefficients from up above, okay? So from that chemical reaction, I'm going to use my coefficients. I'm going to put moles of hydrogen on the bottom and moles of water on the top. And I know that there was 2 moles of water and 2 moles of hydrogen. Now, the reason why I'm doing that is because I want to get rid of my moles of hydrogen. And look, you're just going to multiply 3 times 2 divided by 2. And technically, these 2's are going to cancel out. So that's why your answer here is 3 moles. Okay? It's 3 moles. Again, you do not have to overthink these problems. All you would need to do is just read through what they're asking of you and go from there. Now, if you have a multiple step problem like this one right here, let me show you how simple this is. So I'm going to actually take this same chemical reaction, right? And I'm going to use this. Now, we don't necessarily need the old information because this is a completely different question right here, okay? So for number 2, we do not want to use the old information, all right? Yes, hey, Egypt. Yes, do not. Okay, let me go back up here so that way you can see it, all right? Anytime they say excess something, that just means it's extra. Extra conversation, extra information, TMI. We do not need to know that excess oxygen is there. I mean, that's just there. That's just an extra phrase to throw you off. So what I want you to do is to just simply disregard that and focus on what was highlighted here, okay? Just disregard that. Now, take a look at this next example right here, okay? You're going to still use the same balanced equation for this next part, but you're looking at something completely different, okay? So what do you have to do here? It says, how many moles of oxygen? Okay. Now, let me highlight this one as well so you all can see it. Okay. Here we go. All right. How many moles of oxygen? Now, in this case, they're asking you for oxygens. How many moles of oxygen are needed to react with 4 moles of hydrogen? Okay, they're talking about oxygen and hydrogen. We don't care about water. So what they gave us was 4 moles of hydrogen. Now, here is my question. By what factor did my hydrogen increase by? By what factor? See, my original recipe started off at 2 moles of hydrogen. All of a sudden, it went up to 4. Good, very good, guys. You all said it doubled. That's right. And because it doubled, guess what? Oxygen is going to double, and so is this water. But remember what I said. If they both have the same coefficient, they're going to have the same number of moles. Also, because we know that, I'm going to put a prediction over here, that my moles of oxygen, okay, will be 2.0. We're going to see if that is correct. All right. Watch this. We're going to see if the 2 moles rather, because we didn't have really sig figs to do. So we're going to see if 2 moles will be the answer. Watch this. You've got 4 moles of hydrogen. That's what we're starting with. Now, on the bottom, you're going to go to your balanced equation. All right. Because remember, when I put the box there, that just simply means go to the coefficients of your equation. Make sure you put the same unit on the bottom that you did on the top. See that? And on the very top over here, the one that you're seeking out, you're going to put a new unit there, which is the moles of oxygen, because that's what you're looking for. So you're going to go to your coefficients from back upstairs in your balanced equation. All right. And you're going to write in 1 mole of oxygen from that, 2 moles of hydrogen from this one. And now 4 times 1 is 4 divided by 2. And you got it. We predicted correctly that the answer would be 2 moles, and that is correct. So our prediction was correct. All right, how y'all feeling? Y'all good in there? All right, hey, good morning, Ashley. All right, Arnandia, good. All right. Egypt, we getting there. We're getting there. We're taking it step by step. Trust me. There's always a process to how I do. See, you ask and it shall be given. Y'all ready for the next one? Let's go. Now, I want y'all to brace yourselves. This problem is not difficult either. However, I gotta say, however, I do know that sometimes students tend to think, this looks like some extra stuff. Oh, thank you, Noah. Y'all are so nice. Y'all are so nice. Look at DJ already putting the answer down. But we don't know if DJ is right. But we're going to find out. This one says, what mass? When you hear the word mass, that means I need molar mass. That means the weight. So if I say, what's your weight? You may not want to tell me, but we do know how to calculate the molar mass or the weight for these compounds here, okay? So what you're going to do is determine the mass in grams that is produced when 2 moles of hydrogen react with excess oxygen. Notice I didn't even underline the excess oxygen because we don't care about that, okay? We don't care. So what I'm going to do now is focus on what they are looking for. You're going to go from a mole of hydrogen to a mole of water, like we did earlier. Then convert that to a gram of water, okay? You're just doing one extra step. Okay, DJ. Well, what up, Chemist? What's going on? Haley, you got this. Walk with me through this and you'll get it. So here we go. We're going to take the 2 moles of hydrogen. And remember, during this step right here, let me go ahead and underline this so you all can, and remember y'all, write this stuff down. Write this down. You're going to use your coefficients, okay? From the balanced equation. I'm just abbreviating here because of space, okay? Use your coefficients from the balanced equation. So right here in this box, I'm going to put the moles of hydrogen on the bottom. I'm trying to get to the moles of water that's on top. So let's go to our coefficients to find out what they are. So again, we were dealing with water and oxygen. If you don't see a coefficient, that's an imaginary 1 right there, okay? That's an imaginary 1. So on the top, I'm going to put 2 moles of water. Again, that's coming from this balanced equation. On the bottom, 1 mole of hydrogen. Why did I say oxygen? Look, y'all, got me thrown off. Yeah, there we go. Sorry, y'all. Okay, so it's still the 2 and 2 right there. Okay, my bad. 2 and 2, okay? And now, the next part. And guys, this is how you're able to catch yourself. When you notice that you can't cancel out a hydrogen with oxygen, that lets you know, wait a minute. Oxygen ain't got nothing to do with this. And you don't want to put a different unit on the bottom that cannot cancel out, okay? That's what we're doing. Now, in this last step right here, you're going to use the molar mass calculations. So right here, that's what's going to go there, okay? The grams right here that we already have in the problem. And I'm saving you some time so that you don't have to calculate this yourself. Plus, you should know how to do that if you don't have it given. And on the very bottom, 1 mole of water. Now, we're going to go through, yep, this is General Chem 1. At 11:30, we do General Chem 2. Okay? So, we're going to go ahead and knock out the units. We don't need moles of hydrogen, moles of hydrogen, moles of water, moles of water. What's left over are my grams of water. That's what we were looking for. So if you plug this into your calculator, y'all check it out. These two 2's right here cancel out. So I don't even need to use that. Okay. So what's 2 times 18.02? Letter B, 36. So even if you can't use your calculator, because I know a lot of you all said that your certain tests you take, like the MCAT, you may not be able to use your calculator. So you can do this, okay? Yes, no, I got come through at 11:30. And today we're working on acids and bases and those calculations of Ka, Kb, Kw. Okay? So you come on through that way. Okay, Ashley, yes. Let me go ahead and tell you. Okay, in case your professors do not give you the molar mass, for instance, let me see if we got another one. Okay, yes, I'm going to do this one right here. So that way you can see what's going on. If I do not give you the molar mass, right? Here's how you calculate it. It's real easy. Molar mass. So if you see me write MM, that's molar mass, okay? Because I have oxygen, 2 of them, I'm going to look at my periodic table, and I know it's 16.00. So 16.00 times 2 gives me the 32.00 grams per mole. And those are the units for molar mass. So that's how you find the molar mass. That's like the weight for the element or compound. So speaking of which, let's do this next one then. Okay, well, again, we're using the same formula, the same reaction. And it doesn't matter what I put up here, the process still works the same. Yes, thank you, Egypt. This is why I do color coding a lot, because I know that. Okay, good question, Ashley. Y'all, that's why I'm so glad you all are asking questions. Don't be afraid. I know sometimes you're afraid to ask in your classes, but don't be afraid to ask here, okay? Don't be afraid. Now, the question was, how do I know to go back and look for the mass? Because they're going to ask you, what is the mass of oxygen? If I ask you for the mass of oxygen, you need the molar mass to solve that for oxygen, okay? So if they're asking for mass, you need the molar mass of that element or compound. Okay, so let's do this one, okay? Again, when you read the problem, focus on what you have, okay? Focus on what you have. So let's, for instance, it says, what mass of oxygen in grams is needed to react with 3 moles of hydrogen? Okay. Let's go back up to our equation here and only highlight and focus what they give you. Now, again, I gave you the molar mass, but in case you did not know how to do it, you would have to, if they didn't give it to you, you would have to find it. Now, what am I going to do next? I'm going to take the 3 moles, take the starting number right here, okay? Take that starting number. Matter of fact, let me make this larger. Okay, so we're going to use this whole space right here so that you can solve that. There we go. All right, so because you're looking for the mass, okay, here's what you're going to do. You're going to take that starting number right there, okay? So let me redo that since I made it bigger, threw all the lightings off. Okay, there we go. What mass of oxygen in grams? You need the molar mass that we just calculated. You need that. Will react or is needed to react with 3 moles of hydrogen. So you're going to focus on the given number first. 3 moles of hydrogen times. Now right here in this box, I'm going to go to the coefficients of hydrogen and the coefficients for oxygen. We don't care about water. Leave water out of this. Water ain't got nothing to do with this. All right? You're going to go use your coefficients that I highlighted up above, that 2 and the 1. And guess what? We're going to put them in our problem. We have 1 mole of oxygen and 2 moles of hydrogen. Again, those are coming from the highlighted parts. Times. Now, right here, remember, step 1, if we go back up here to our steps, guys, use the coefficients from your balance equation in that box. Step 2 is to now multiply times your molar mass weight, okay? You're going to multiply that. So right here, I'm going to put 32.00 grams of oxygen on the bottom 1 mole of oxygen, okay? And y'all listen, if you all need help, if you want tutoring, y'all can come to me. My special rates are on sale right now, okay? So if you want help, y'all got to come through. Otherwise, go to your tutor center. That's what your tuition is paying it for, okay? Go to your professor office hours. Don't be scared of them. Go seek them out, okay? Now, moles of hydrogen goes away. Moles of hydrogen goes away. Moles of oxygen goes away. Moles of oxygen goes away. What's left over is what you were looking for, which are my grams. So multiply 3 times 32.00 and then divide it by 2. Okay? Okay, the question is, why wouldn't it be 2 moles of oxygen? It says, oh, good question. It's the coefficients that you must use. The number in front, not the number on the bottom. You use the number on the bottom when you're getting the molar mass, but when you are getting the mole to mole stuff, the ratios, it's this number right here, the coefficients. You know what, y'all? I think I need to say this because y'all got some really good questions. I'm going to finish this one out and then I'm going to actually I'm going to walk y'all back in baby steps, okay? 3 times 32.00 and then divide that by 2, you get 48. So the answer to this one was letter C, okay? Letter C, right here. 48 grams. Yes, that's right, Ashley. It's for the molar mass. Exactly. Oh, Jessica, yes. Well, honey, I got, if you need some help, come on through, okay? Come on through. Matter of fact, I go live Monday through Thursday at 10 a.m. Eastern Standard Time and 7 p.m. Eastern Standard Time, okay? And I have the patience to help you guys. So don't think that you're asking me irritating questions. But let me walk you all through something because I feel like I need to share this with you because some of y'all are asking really good questions about how do I know this? How do I know that? When do I do this? When do I do that? So let me explain this one to you. Okay, I'm going to say something here in baby steps. All right, because I feel that needs to be addressed. Okay, we need to basically dissect what this whole thing right here means, okay? We're going to dissect this, all right? We're going to dissect it. All right, I'm making it big, so y'all, well, not that big. Okay, let's dissect what's in our recipe. As a chemist, what you talking about, Aaron dear? All right. As a chemist, this is my recipe. So y'all know how y'all go on the back of a recipe label and it tells you to put this in the oven at 350. They tell you you need 2 cups of this, 1 teaspoon of that. That's what this is. So as a chemist, I know I'm working with 2 moles of hydrogen, 1 mole of oxygen, 2 moles of water. This also tells me 2 liters, because I can use this as volume. 2 liters of hydrogen, 1 liter of oxygen, 2 liters of water. Now, if I say I want to know specifically, what's the grams of this, I will use the subscripts, because that means I have to use the molar mass for that part. Okay, to get the grams of something, I need to get the molar mass of whatever I'm looking for. Also, if I'm doing a mole to mole ratio, I'm using the coefficients. All right, coefficients. Now, I'm going to do this. I'm going to break it down in terms of a recipe, so you all can kind of digest this even more. All right, we're getting ready to take our first meal, right? If it takes 2 eggs, okay, plus, let's say, 3 pieces of bacon, turkey bacon, beef bacon. They even have beef bacon. Yeah, turkey bacon, pork bacon, whatever you eat, all right? 2 eggs, 3 pieces of bacon to give me a sandwich, right? 1 sandwich. I'm getting ready to flip this recipe. All right? I'm getting ready to flip this recipe so you all can get this. All right? Yes, Mercedes, that is correct. That is correct. Okay, that is correct. So here's what you're going to do right here. It says, if I tell you that you have 2 eggs plus 3 pieces of bacon to give me 1 sandwich, what happens if I said, you know what? I want 6 eggs now. Give me the other numbers now. Give me the missing pieces now. All right. How many pieces of bacon am I going to use in this problem now? D-Res 97, you better not be failing chemistry. Okay, call me Bubba. You said 9. You are correct. 33, 1 forever. You are correct. Y'all got this. How did you know it was going to be 9 pieces of bacon? How did you know? And how did you know it's going to produce 3 sandwiches? How did you know that? Right, because you multiplied everything by 3. Exactly. Everything tripled. Once you know the starting thing, that means everything else is going to do the same thing. Y'all, it's the same process. It's the same process. But if I ask you, hey, we need to go to another country and do the same thing there, well, then we would have to convert it additionally, because now you're talking a whole different conversion system. Okay, let's do another one, because I want to make sure y'all good. All right, we're going to do another one. All right. And then we're going to go back to what we were doing just to show you guys is nothing more to this process. What if I said I want to make 10 sandwiches? Thank you, Mercedes. I appreciate you. If I want to make 10 sandwiches now, y'all tell me, how many eggs am I going to use? How many pieces of bacon am I going to use? Just put your answer, like whatever the number is, comma, whatever the other number is. Anna G said 20 and 30. We don't need bread. Stop trying to add stuff that ain't got nothing to do with it. See, that goes back to that excess oxygen part. That's TMI. We ain't talking about no bread. We just only asking you about what you see right here. Okay? Yeah, y'all be trying to do extra. Yes, the answer is 2030. All right? Who said 5 eggs? Why'd you say 5 eggs? Or did you mean 5 times? Or wait, what you talking about? Maybe that was a typo. Thank you, Egypt. Everything increases by the same proportion. That's how mole to moles work. So if I flip this same thing and I now throw in chemistry symbols is like ingredients. Chemistry symbols are like ingredients. Okay? Now, if I told y'all to go and convert 3 pieces of bacon, that's veggie bacon, convert that to some pork bacon, then that's where you're talking about grams. That's a whole nother funky type of equation. Okay? But that's where you get into grams though. All right? So if we go back up here, y'all, I'm trying to make sure y'all get this. Okay? That's why I am passionate about how I'm explaining this stuff to y'all. So let's go back over here. Okay? Because next up, we got grams to moles. And before we go any further, okay, let me clear my throat. Hold on, y'all. let me pause this so y'all don't hear me all on there. Hold on. All right, here we go. Let me tell you all how the gram stuff works, okay? The gram, and I'm not talking about IG. I'm talking about the gram here, okay? The grams here. Let's say that we're here in the United States of, okay? And we know that $1 equals 4 quarters. Well, no. We know that here in the U.S., $1, it ain't really worth a whole lot, right? And so if we go to another country, let's say we're going to France, and let's say that 10 francs, okay, equals $1. Well, this is the conversion right here. This is where you go into the grams to moles and moles to grams stuff right here. That's right, honey. Money always works. And that's why I use money as examples. Now, $1.29 is equal to 1 Swiss franc. Okay, so I was overbidding us, okay? And so just as an example, if 1.29 francs, okay, well, they call it Swiss now, but I'm saying francs because that's what we use when we was in school, okay? Anyway, so if $1 is equal to $1.29 in francs, here's what I want to know. What if I have a band, okay, 1,000, and I need to convert that to a franc? This means that my $1 is going to equal to $1.29 francs, okay? So all you have to do here is convert by multiplying 1,000 times 1.29. Let's see what that's equal to. $1,000 times 1.29 equals 1,290. So if we go back over here, just so you can check, okay, we have $1,000. Hold on. I had their conversion wrong. Hold on, y'all. I said $1. Oh, it's equal to 0.77. Okay, 0.77. Good morning. That's even less. 0.77, y'all. My bad. 0.77. Okay, so right here, if the US dollar is equal to 0.77 francs, how much is that equal to? All you have to do is say 1,000 times 0.77, and that gives you $770. So what am I showing you all here, right? I'm showing you guys, no, I'm trying to explain how to do these conversions here to make it easier. Because we're talking about conversions. And if I were to say go from a gram to a mole, this is the same thing right here. This is why I'm trying to show this to you all so you can see the real life applications. So if you're going to go to some other country, you've got to convert your money to their money. Well, guess what? Just like I said, the recipe here is the same thing in terms of converting, food to a chemical formula. Money is the same thing. Okay. So now we're going to do grams to moles. Earlier we were doing moles to grams. So now we got to walk backwards. Okay. We got to walk backwards. Now walk it out. Walk it out. We got to walk backwards. Okay. So here it is again. Okay. Walk with me. Walk with me. How many moles of hydrogen are needed to produce 72.08 grams of water? Now notice I've already given you your water, right? The molar mass for water. I've already given that to you. But in the event that you did not have it, you would need to know how to calculate molar mass. Remember, molar mass is equal to 2 times 1. I'm just going to times 1.02 times 16. I mean, plus 16, excuse me, plus 16. Okay. So you're doing 2 times 1.02, which is the mass for hydrogen, plus 16.00, which is the mass for oxygen. 2.02 plus 16.00 gives you that number right there. Okay. Now, to get this next answer right here, let's go back. We're focused on hydrogen and water. Okay. Hydrogen and water. It says how many moles. So for this problem, y'all, you're going to have to go from the grams of water to the moles of water to the moles of hydrogen. So you are walking backwards. Oh, Lord, no, Mercedes, you do not need to memorize the atomic masses for that. No. As a matter of fact, they're going to give those to you. Yeah, they'll give them to you in the problem. Like they'll have a box of whatever that compound what that element is equal to. So like they'll say hydrogen and 1.01 like that. But no, you do not have to memorize that. All right. So now what is the next step? Okay. To go from grams of water to moles of water, use this number right here. Remember that Frank's conversion thing that I talked about? Up yonder ways, up here. Okay. You're going to do that down here. Okay. So you're going to say 72.08 grams of water times right here. I'm going to put that 18.02 grams of water on the bottom because I need to cancel out that conversion of that gram. And on the top, 1 mole of water. This is just like me saying we're going to go take our US dollar and go to another country. That's what this is right here. We're dividing, all right? Then in this last step, you're going to go to those coefficients, all right, from your balanced equation. So up here, that 2 and that 2, you're going to use both of those right there, all right? So on the bottom, I'm going to put 2 moles of water so I can cancel it out with the top one. And what I was looking for was the moles of hydrogen. So again, cancel out the units you don't need anymore. And those are gone. Now, y'all, technically speaking, these 2 2's right here can cancel out because they're the same number. So technically speaking, we can just go ahead and knock those out too. And just do 72.08 divided by 18.02. All right, here we go. 72.08 divided by 18.02, and you get 4. So for those of you all that said 4 for letter B, you are correct. You are correct. Now, if you're like, nah, I'm gonna have to multiply all those numbers, don't be canceling those numbers out on me because I might get confused. All right, say less. I got you. We can go ahead and put them back there. The outcome is still going to be the same, but I'll show you. 72.08 times 2 divided by 18.02. Divide that again by 2, and you get 4. All right? That's right. Woohoo! That's right. Okay. Okay, very good question. I thought moles equals grams times molar mass. Why did you divide the grams and molar mass? Okay, right here at this step, I'm glad you asked that question. All right, take a matter of fact, I'm gonna highlight it in yellow. You see this? Because we're trying to, hold on, y'all, hold on. Because we are trying to get rid of the gram, you got to have a gram on the bottom. But let me go back up here so you can see the difference. See how the gram is on the bottom here, right? Well, earlier, the gram was on the top because we were trying to get to it. So let me say this, so that way you all will remember this part, okay? Whenever you are in chemistry, when you're going from a gram to a mole, you're going to divide by the molar mass. When you're going from a mole to a gram, you're going to multiply by the molar mass, okay? That's the difference. When you're going to a mole from a gram, you divide by the molar mass. When you're going from a mole to a gram, you multiply. So, mole, gram, okay? Mole, gram, multiply. But when we were down here, gram, mole, we divided. Now, I don't go live on Fridays. Yes, I don't go live on Fridays. I just do Monday through Thursday, Ashley. But I will be back tonight. And you know what, too, y'all? Sometimes you guys need an extra tip of information. So I have this. Oh, thank you. Hello, fellas. Thank you for the roses. Sometimes you all need to have something that's going to give you quick tips. So I actually created this 11 by 17 guide to help you all come up with ways to remember certain things. Okay, so this is like your mole map. So if I say to go from grams to moles, you're going to divide by the molar mass. Moles to grams, multiply. You know, I have this little quick tip here. Oh, thank you, Senia7. Thank you. Thank you, thank you, thank you. Okay, so that way you all remember those things. Now, speaking of which, y'all, we got to do another one because I want to make sure y'all are good. Okay. Again, we've been working with this same chemical reaction because it doesn't matter what the formula is can you do the problem? Okay. So I've been working with the same process because I want you guys to see that no matter what we change, the output is still the same. Yes, you get it from right here. Yep, right there. Okay. Now, on this next problem, how many moles of oxygen are needed to react with 8.00 grams of hydrogen. I've given you the molar mass right there. Here's what you need to know. Hydrogen and oxygen. We don't care about the water, all right? Not in this question, but we do care about the water in the environment. Side note. Okay. They're asking you to go from grams of hydrogen to a mole of hydrogen to the moles of oxygen. Use those steps, okay? Use these steps as you go through your process. In order to do this first step right here, you need the molar mass for hydrogen. And you have to divide by that molar mass. To go from this step right here, you need to use the coefficients, okay, from your balanced equation. All right, those are the steps. Y'all take screenshots, okay? So that way you'll know when you do this on your own. All right, let's go ahead and do this problem. Breathe in and out so you can relax and focus on what you got. All right, you've got 8.00 grams. Always start off with the first number they give you in the problem. Times. Remember, because we're going from a gram to a mole, we divide. That means you got to put that 18 point, I'm thinking about the number from before. You've got to put that 2.02 grams of hydrogen on the bottom, this number right here, and on the top, the 1 mole of that on the top. And then times, and this step right here, use that 2 and that 1. 2 moles of hydrogen on the bottom, 1 mole of oxygen on the top. And y'all, as you go through each of your steps, start canceling out what no longer serves you, what no longer you're needing. All right. What's 8 divided by 2? 4. What's 4 divided by 2? 2. So, who said the answer is letter D? It ain't D. 8 divided by 4.02 gives you 2. Okay? The answer is B. This one right here has even more, one extra step. Okay, I won't say more steps, but I mean, it is one extra step, okay? So, I want you all to look at this problem. And because it's gram to grams, you're going from grams of one thing to the grams of something else. This one is going to require you to do an extra step. Okay, so let me show you. Right. So this is a 3-step problem. Up here, let me put the steps so that way you all going to know what I'm talking about, okay? Mole to mole. Matter of fact, I'm going to write this out so y'all can see this. Mole to mole, 1 step. Okay? 1 step. Mole to moles, 1 step. Mole to grams, 2 steps. Mole to grams, 2 steps. Grams to moles, still 2 steps. It's just the reverse of what I just said a second ago. Grams to moles, 2 steps. Now down here, gram to grams, 3. steps. Trois, three. Tres. Okay? How many ways you can say three? You're going to go from a gram of oxygen to a mole of oxygen to a mole of hydrogen to the grams of hydrogen. Okay, those are your steps. And we're going to take it nice and slow. Here we go. What mass of water? Okay, what mass of water is produced when 16.00 grams of oxygen reacts with excess hydrogen? Remember what I said? Excess means TMI, too much information that we don't care about. Ignore that excess hydrogen. Excess, okay, and so what you're going to do, and I have not thanked you guys enough. Thank you so much for your follows and your reposts and your shares, your tags. I appreciate all of that. The gifts. Thank you all so much for all those kind gestures that you all have been doing every time I go live. I appreciate that. All right, Abby, walk with me then. Walk with me. We're going to walk slow. First up, notice I gave you the molar mass for oxygen and for water because you're going to need them. You're welcome. Hello, fellas. Yes, you're welcome. All right. You're going to take the 16.00 grams of oxygen. And if I talk slow, I'll probably write neater. You're going to take the grams of oxygen and you're going to divide it by the molar mass of oxygen. Right here. On the bottom, 32.00 grams of oxygen. On the top, 1 mole of oxygen. Thank you for the roses, Egypt. I'm going to cancel my grams out of oxygen because we're done with that step. Now, I'm going to move on to moles of oxygen to moles of water. So you go back up here to your balanced equation, and you only need the moles of water, and you only need the moles of oxygen. Use those two that I highlighted right here in this next step. So right here in this top box, I am going to put the number that we need for water, okay? So on the bottom, I'm going to put the moles of oxygen, which is 1. On the top, moles of water, which is 2. Again, cancel out those moles of oxygen. You don't need them anymore. And then the last step right here, use the molar mass of water. Okay? Use that last number right there. Remember, because we're now going from a mole to a gram, we have to multiply by the molar mass. So that's where your 18.02 grams of water comes in over 1 mole of water. Okay. The question was, let me go back. How do you know which one goes on the top or the bottom? It's what you're trying to get rid of, okay? So let me zoom in so you can see this. Okay, if we look at this first step right here, I started off with the grams. I need to get rid of the grams. That's why I put 32 on the bottom. That 32 right there went on the bottom. If I would have put it on the top, 32 grams on the top and 1 mole on the bottom, I cannot cancel them out. So whatever you start with, you want to put it on the bottom so they can cross out. Hey, I started with the oxygen on the top here. I'm going to put the oxygen on the bottom there. And this 2 and that 1 comes from the coefficient of the 2 and the 1 here, from your balanced equation. The last step, to get to the grams, I have to multiply times the molar mass. So I have to multiply by the molar mass of water, which is this number right here. And when you put all that together, you're just going to multiply it, okay? You're going to multiply it straight across. Oh no, the reaction's going to be given. Yeah, the reaction's going to be given. You're welcome. Yeah, the reaction's going to be given. Now, whether it's already balanced or not, if your teacher wants to challenge you, then that's up to them, okay? Now, let me show you something else too, another little trick. Y'all, when you get comfortable with numbers, you'll begin to see how, what's 16 times 2? 32. What's 32 divided by 32? 1. What's 1 times 18? 18. When you get comfortable doing these numbers, you ain't got to plug all that in. But just in case you want to know, let's do it. 16 times 2 times 18.02 divided by 32 gives you 18.02. And just like that, we still end up with letter B. Okay. So again, you always get rid of units that you don't need anymore. And that's how you know if you cross them out. If you started with 1 at the top, put it on the bottom, cross them out. New unit on the top, put the new unit on the bottom also, cross them out. New unit on the top, unit on the bottom, cross them out. Exactly. You're multiplying across and then dividing by what's on the bottom. All right. Thank you, Jamie. All right. Okay. Now, I may have one more in here. And do. Okay, let's see. But I want you all to be confident in what you are doing so that you too can make an A on your test. Okay, y'all stop playing. Focus. Lock in. Lock in. Lock in. I cannot say that enough. You all got to focus. Stop giving up on yourselves, because a lot of y'all are saying, man, I don't get this. I don't know. I'm just going to fail this test. And you know what? You're right. You sure are. So if you keep saying that, that's exactly what's going to happen. You got to have faith in yourself, but you got to put in the work, though, in order to maintain that thought process of I can. I know I can. You got to keep doing it. You got to keep saying it over and over and over. If you don't believe in yourself, yeah, you're right. It ain't going to work. It is not going to work. So with that being said, I'm canceling out these grams. This is the first step. Take the starting number, 64.00 grams of oxygen, Cancel that with the 32 grams of oxygen on the bottom. That's the only way this is going to work. You cannot put 32 on the top. But finally, you can get this in my portal. I have a portal of massive amounts of worksheets, study guides, videos, quizzes, everything that you want to succeed in chemistry. I have it up top. Go upstairs to the BIO and hit that LINK. 1 mole of oxygen is on the bottom. 2 moles of hydrogen is on the top. Again, we're going to cancel the moles of oxygen. And now in this last step right here, we were trying to get to the grams. So 2.02 grams of hydrogen is on the top with the 1 mole of hydrogen on the bottom. Thank you, Eric. Cancel those out. Y'all, go ahead and make that math work. What's 64 times 2 times 2.02? And then divide that by 32. And you get 8.08, letter C. Okay, letter C. So if you all got it right, put a purple heart in the comments. If you got this question right, put a purple heart in the comments.